Is looking for Wi-Fi access points purely passive? Say I carry a Wi-Fi enabled phone or laptop through an area where there are WAPs. Assuming that I don't actively try to connect to them or otherwise interact with them, is it possible for the owner of that WAP to know that I was there? I'm asking this in the context of my earlier question, looking for Macs on the network. I was talking with a friend about my newfound ability to detect phones and other devices with MAC addresses on the network, and he pointed out that it might be useful to detect unknown phones on the network. I could use that data to track down anyone who was in my house and brought a Wi-Fi phone with them. So, if I set up a logging fake WAP with no security or encryption, can I glean any useful information about the devices that come into the house? Assuming that the thief doesn't actively try to connect.
No, looking for 802.11 APS is primarily active. When you bring up a list of visible APS in the area, your 802.11 client most likely does what's known as an active scan, where it tunes its radio to each supported channel in turn, transmits a probe request frame, and waits perhaps 20 to 40 milliseconds to gather probe response frames from any APS on that channel before moving on to the next channel. This allows it to scan all the channels much faster than a passive scan. A passive scan is possible, but it isn't used very often because it takes longer. To do a passive scan, the client tunes to each channel in turn, and waits a typical beacon interval, usually about 100 milliseconds, but could be more, to gather beacons. Some channels in 5GHz in some regulatory regions require that you scan passively first, until you know that the channel is not in use by nearby radar installations. But most clients, as soon as they see a beacon on a passive scan channel, will switch to an active scan to speed up the process. If your client device is on, and hasn't given up looking for your recently joined/preferred/remembered networks, it will almost certainly be broadcasting probe requests which give away not only your wireless MAC address and some of the capabilities of your card, but often also the name the network it's looking for. This is necessary in case the network is a hidden, aka non-broadcast SSID, aka closed, network. It's pretty trivial to learn people's wireless client MAC addresses and also the names of their home and work networks just by hanging out at the office or a coffee shop or airport terminal with an 802.11 monitor mode packet sniffer, recording probe requests.
There is a system called Jassager that detects Wi-Fi probes that most clients shout out, "Hello, is Linksys there?" etc., pretends to be it, lets them automatically connect as if they are at home, with that lovely public networking option Windows now has. Lo and behold, all their public file shares, web traffic, and there are extensions for it that let you attack SSL sessions, and anything else you can think of. Enjoy and don't get caught.
This recent paper presented at the Internet Measurement Conference 2013 might be interesting to you. Signals from the Crowd, Uncovering Social Relationships Through Smartphone Probes. Abstract. The ever-increasing ubiquitousness of Wi-Fi access points, coupled with the diffusion of smartphones, suggests that Internet every time and everywhere will soon, if not already has, become a reality. Even in presence of 3 grands connectivity, our devices are built to switch automatically to Wi-Fi networks, so to improve user experience. Most of the times, this is achieved by recurrently broadcasting automatic connectivity requests, known as probe requests, to known access points, APS, like, for example, home Wi-Fi, campus Wi-Fi, and so on. In a large gathering of people, the number of these probes can be very high. This scenario raises a natural question: Can significant information on the social structure of a large crowd and on its socioeconomic status be inferred by looking at smartphone probes? In this work we give a positive answer to this question. We organized a 3-month-long campaign, through which we collected around 11 meters probes, sent by more than 160k different devices. During the campaign we targeted national and international events that attracted large crowds as well as other gatherings of people. Then, we present a simple and automatic methodology to build the underlying social graph of the smartphone users, starting from their probes. We do so for each of our target events, and find that they all feature social network properties. In addition, we show that, by looking at the probes in an event, we can learn important sociological aspects of its participants' language, vendor adoption, and so on.
I recommend you get hold of Backtrack and try running AirDumping, or else install AirCrack if on Linux. That'll show you what's going on with the devices and whether they are visible, probing for network addresses. You can use airbasing to act as an access point. Note there may be legal issues around doing this depending on what country you live in.